our function. If I asked you first just to find some values, f of 0, that's saying x is 0, so which piece would I use? The second one. And what do we get out? Not 0. 1. Yes. The second one, f of 1. So when my x is 1, which piece do I plug it into? The first, so 2 times 1 is 2. And f of 2. When my x is 2, we're putting it in the, so 2 times 2 is 4. Okay, let's wait and do the domain after the graph. I think it's easier to graph it first. So if I make a t-chart, how many t-charts would we need here? Okay. What am I plugging into the first t-chart? Anything but 0. And really, I probably should put in a 0 as well, but what would it be? Open circle. So I'll go ahead and maybe do like -1, 0, and 1. And 0 I know is really open. So if I put in -1, 2 times -1 is -2. Put in a 0, 2 times 0 is 0. Put in a 1, 2 times 1 is 2. So if I'm graphing these, I had -1, -2, 0, 0 is open, and 1, 2. So this is just a line with a y-intercept of 0, slope of 2, that has an open circle in the middle. For my second t-chart, what do I have to plug in? Just 0, and that's the only thing. And if I put in 0, we get out 1. Okay. So far, so good? So then we've got our graph looking at our domain. Domain is talking about our x, so we just have that one point at 0, 1. If I'm looking at this, going from left to right, is there any x value we don't hit? No, we hit them all, so my domain would be my range is talking about my y. So if I go from the bottom up, this end's going down forever. So I'm coming up. Is there anything I don't hit? 0. So how would we write that range? So part D. Part E, is this graph continuous? No, that's a break in it. We can give sections of it that are continuous, but I just asked if it was continuous everywhere. So my answer would be no there. So we looked at those yesterday. Is that okay with everyone? Let's talk about the greatest integer function. Okay. This is the one, it typed kind of weird, but it's really just that double barred bracket. And what the greatest integer says is you can't get out anything bigger than what you plug in. And you only get out integer answers. When I say integers, I'm meaning -2, -1, 0, 1, 2. So we're never going to get out decimals, fractions, and those kinds of things. So let's just start with a nice one. If I put in 0, 0 is an integer. So if you put in an integer, that's what you get out. So if I put in 0, I'm going to get out 0. Now if you just put in a 1, what are you going to get out? 1. And is that really telling me what this graph looks like? Greatest integer, we need to do some decimals or fractions. Okay. So let's say I put in 0.5. 0.5 falls between 0 and 1. The greatest integer says you have to get out an integer, but you can't get something bigger than what you put in. So what's it going to give me out? Still 0. What if I said 0.9? That falls between 0 and 1, still getting out 0, because I can't get anything bigger than what I put in. If I put in a 1, though, what do we get out? We get out of 1. Okay. I'm going to maybe count by halves on my graph so I can show this a little better. So if I'm plotting this, we had 0, 0, 1/2 still gave me 0, 0.9 still gave me 0, but when I put in 1, I got out 1. You are down here getting out 0 up until the very end when you put in 1. So what do I need to put down here? Open circle. Okay, the greatest integer function is nice. Once you get one step, you really have the whole graph. So what we can see is our steps are 1 unit long, and then you jump up to the next one. So I get 2, we'll jump up to 2, and we'll stay there until we get to 3. And we'll jump up to 3 and stay there until we get to 4. And then you can go the negative direction as well. Circle on the left, open on the right. What I ask when you graph these, I want you to draw at minimum 3 complete steps, and then if you just want to put like ... to show it keeps going, that's fine. Or you can take it all the way out to the edge. But if you just stopped, after a couple steps, I don't want you to think that your graph just ends there. If that's all you drew, then you need to put some ellipses there to show me that you understand it keeps going. Okay. What's the domain of this one? Yes, negative infinity, positive infinity. We hit everything eventually. What is the range? What y values do we get out? I'm not getting every single number, am I? All the integers. Do you guys remember the symbol for integers? It's like a double barred Z. That means integers. You could also say like ... and start listing out some of them. ... show me you understand that's not everything. It does keep going both ways. So a couple different options for writing that. Give you an ugly one, right? One greatest integer of 1/3 x minus 2. So let's make our t-chart. We have to figure out one complete step, and then we know we can just extend our path. So what do you want to plug in first? 0. 1/3 times 0 is 0. So you get the greatest integer of -2, which is -2. Okay, since I got an integer out exactly, I know that is the beginning of a step. So now we just need to figure out how far we go until we get the next integer. What do you want to plug in? 1. If I put in a 1, 1/3 times 1 is 1/3, minus 2 is -5/3, or -1 2/3. Seems like the negatives kind of throw me. -5/3 falls between -1 and -2. You have to give me the smaller number. So what's smaller? -2. So 1 still gives me out -2. If I put in a 2, 1/3 times 2 is 2/3, minus 2 is -4/3. So that's like -1 and 1/3. Again, that's between -1 and -2, so what do we get out? -2. So I'm still on the same step. What happens if we put in a 3? 1/3 times 3 is 1, minus 2 is -1. Greatest integer of -1 is -1. So I got out that integer exactly. I know that's the beginning of the next step. So at 3 we jump up to -1, so I have to put an open circle below that. So now I can see my path. My steps are 3 long, and then you go up 1. So that means I'll stay on this step until when? 6, because we stay on it for 3, and then we'll jump up 1. Stay there until 9, and then jump up. Minimum of 3 steps. I don't care which way you extend it, just enough to show me that you understand your pattern. Questions there? The last couple problems on the homework, or maybe they weren't even the very last, there was one that gave you a scenario in words and asked you to draw a graph for it. So I just wanted to practice one of those. An express mail company charges $20 for a package weighing up to 2 pounds and $2 for each additional pound or fraction of a pound. Let y equals c of x represent the cost to send a package weighing x pounds. Graph y equals c of x for the interval 0 to 6. So I'm not even asking you to write an equation. I just want you to draw me a graph. My x's have to go all the way up to 6. What is the least amount I'm going to pay to mail this package? $20, right? So I need to make my y go past 20 for sure. I'm going to count by 2s, and I'll just label every other one. Hopefully I gave myself enough space there. Okay. So let's start graph. If your package weighs half a pound, how much are they going to charge you to mail it? It charges $20 for a package weighing up to 2 pounds. So if it weighs 2 pounds exactly, you're still paying $20. But you also pay that for anything less. So if it's a 1 pound package, you still pay $20. If it's half a pound, you still pay $20. If it's a tenth of a pound, you're still paying $20. Now, will you actually mail a package that weighs 0? Absolutely 0? So what kind of circle should this start with? Open. You also could have got that from the interval because I said parenthesis, which means starting with an open circle. So I'm going to put an open circle at 0 to 20. Then I'm going to stay on that line. Now, as soon as your package goes past that 2 pound mark, so if it weighs 2.01 pounds, what do they do to your cost? They add $2. So after 2 pounds, my price is now $22. How long do I stay there? For each additional pound. So until I get to 3 pounds, it's still going to stay at that. So at 3 pounds, you're still paying 22. What kind of circle should this step start with? An open. Okay, because at the 2 pounds, you're still paying just 20, but as soon as you go past 2 pounds, now you're up to 22. Okay, when you go past the 3 pounds, what do you pay? 24. It goes up another 2, and you're going to stay there until you get to 4 pounds. So then we go up to 26. And we're going to stay there until we get to our 5 pounds. And then we go up to 28, and we stay there until we get to 6 pounds. So we didn't need the equation, we just kind of worked through the problem there. Any questions on that one? I just asked for a graph, I didn't ask you to do anything else. Very last example then. So graph x equals y squared. If I want to graph that, what should I do? Yeah. If you want to use your calculator, you have to get rid of the square. We could just make a t-chart too, pretty easily. Would it be easier to plug in numbers for x or for y? Probably the y, since we're going to square that. Okay, so if I put in a -2, -2 squared is -1 squared, 0 squared, 1 squared, 2 squared. Let's plot it. Okay, 4, -2, 1, -1, 0, 0, 1, 1, and 4, 2. So what's this graph look like? So is it a function? No, it fails the vertical line test. What's the domain of this? Right, bracket 0, infinity. What's the range? Negative infinity, positive. Good. All right, that's the end of my notes. So yesterday I went ahead and gave you guys the assignment, and it's also printed on there. You have the rest of the hour to work and ask for help when you need it. Answer keys in the folder over there if you get to that point and want to check what you've done.